November 8th, 1942. 0300 hours. The beaches near Oran, Algeria. Unteroffizier Klaus Fischer of the Wehrmacht's 334th Infantry Division crouched behind a concrete pillbox, watching dark shapes emerge from the Mediterranean surf. The Vichy French defenders had collapsed faster than anyone expected, leaving German advisors to face the American invasion force alone. Fischer, a veteran of Poland, France, and 2 years on the Eastern Front, had seen every weapon the modern world could throw at a soldier. He'd faced Polish cavalry charges, French tank assaults, and endless waves of Soviet infantry armed with everything from ancient Mosin Nagants to captured German weapons. He'd survived all of it through a combination of superior training, superior tactics, and the reliable Mauser-Car 98K bolt-action rifle that had served Germany since 1935. As the first American soldier splashed onto the beach, Fischer raised his Mauser, worked the bolt to chamber a round, and took aim at a figure roughly 200 meters away. He squeezed the trigger. The rifle barked. The American fell. Fischer worked the bolt again, up, back, forward, down, ejecting the spent cartridge and chambering a fresh round. The entire motion took perhaps 1.5 seconds. He'd performed it thousands of times in training and combat. He was good at it. He fired again. Worked the bolt. Fired. Worked the bolt. Then the Americans fired back. What Fischer heard in those next seconds would haunt him for the rest of his life. Not the crack of individual rifle shots, but something else entirely. A sustained roar of semi-automatic fire that sounded less like riflemen and more like a firing squad. The concrete around his position erupted in chips and dust. Bullets whined past his head in a continuous stream. He ducked below the pillbox wall, pulse racing, mind struggling to process what he'd just experienced. "They all have machine guns!" someone shouted in German from the next position. But they didn't have machine guns. What they had was something the German army hadn't fully anticipated, hadn't adequately prepared for, and would come to fear across 3 years of brutal combat. The M1 Garand semi-automatic rifle. While Fischer worked his bolt-action rifle, firing one shot, manually cycling the action, firing again, each American soldier had fired 8 rounds as fast as they could pull the trigger. 8 aimed shots before reloading, 8 opportunities to kill. And when those 8 rounds were exhausted, the rifle automatically ejected the empty clip with a distinctive metallic ping, and the soldier slapped in a fresh clip and fired 8 more. The mathematics were brutal and simple. In the time it took a German soldier with a Car 98K to fire 5 carefully aimed shots, working the bolt between each one, an American with an M1 Garand could fire 8 rounds, reload, and fire 8 more, 16 shots to 5. And unlike machine guns, which fired from fixed or prone positions, every single rifleman in the American infantry could deliver this firepower while moving, while advancing, while assaulting a position. Fischer survived that night. Many of his comrades did not. And as dawn broke over the Algerian coast, the survivors asked each other the same question in hushed, frightened voices. What kind of rifles do the Americans have? This is the story of the M1 Garand, the first standard-issue semi-automatic rifle in military history. The weapon that gave American infantry a firepower advantage so overwhelming that German soldiers initially refused to believe it was real. The rifle that General George S. Patton called the greatest battle implement ever devised. And the engineering marvel that transformed American infantrymen from competent soldiers into the most lethal individual combatants in World War II. This is the story of how one Canadian-American gun designer named John Garand created a weapon so revolutionary that it redefined infantry warfare, how German soldiers discovered, often fatally, that their doctrine was obsolete, and how the distinctive ping of an ejecting clip became the sound of American victory. To understand the revolution the M1 Garand represented, we must first understand the world it shattered, a world where every major military power armed its infantry with manually operated bolt-action rifles that had changed remarkably little since the 1880s. The German Karabiner 98 Kurz, the Kar 98K, was a shortened version of the Gewehr 98 rifle designed in 1898. It fired the powerful 7.92 by 57mm Mauser cartridge, held 5 rounds in an internal magazine, and required the shooter to manually work a bolt handle between each shot. Up, back, forward, down. eject spent cartridge, chamber new round, cock firing pin. In expert hands, a trained German soldier could fire 15 aimed rounds per minute, perhaps 20 if rushed and accuracy wasn't critical. The British Lee Enfield, arguably the finest bolt-action rifle ever made, could fire faster, up to 30 aimed rounds per minute with a skilled operator, thanks to its smooth bolt action and 10-round magazine. British mad-minute drills had soldiers firing 15 rounds in 60 seconds at targets 300 yards away with every shot expected to hit. The Soviet Mosin Nagant, designed in 1891, was crude but effective. 5-round internal magazine, brutal recoil, sufficient accuracy. It had armed the Tsar's armies, then the Red Army, and would continue serving into the 21st century. The American Springfield M1903, adopted in 1903, was an excellent rifle, accurate, reliable, well made. It fired the powerful .30-06 Springfield cartridge from a 5-round internal magazine. American soldiers in World War I had used it to great effect. By all conventional measures, it was a world-class weapon. Every major military in the world had settled on the same basic solution: a magazine-fed bolt-action rifle firing full-power cartridges. The design had proven itself in the Spanish-American War, the Boer War, World War I, and countless colonial conflicts. It was mature technology, reliable, relatively cheap to produce, and in the hands of trained infantry, devastatingly effective. The problem was that this technology had a hard ceiling. No matter how well trained the soldier, no matter how smooth the bolt action, there was a physical limit to how fast you could manually cycle a rifle between shots. And in that brief moment, that 1.5 seconds, while working the bolt, the soldier wasn't aiming, wasn't firing, wasn't killing the enemy. He was vulnerable, he was mechanical, he was limited. Military theorists had long recognized that if you could eliminate that manual cycling, if you could make the rifle fire every time the trigger was pulled without any other action required, you would fundamentally change infantry combat. The question was how. The idea of a self-loading rifle, one that automatically chambered the next round using energy from the previous shot, was almost as old as the metallic cartridge itself. Inventors had been tinkering with semi-automatic designs since the 1880s, using various mechanisms to harness recoil energy or gas pressure to cycle the action. Some designs worked, after a fashion. The Mexican Mondragon rifle of 1908 was arguably the first semi-automatic rifle to see military service used briefly by Germany during World War I in the aircraft observer role. The French had experimented with the RSC ML 1917 and Memsel 1918 semi-automatic rifles, issuing limited numbers to select troops. The Americans had the Peterson device, a complex conversion that turned the Springfield bolt action into a semi-automatic firing pistol caliber ammunition. But all of these designs shared common flaws. They were complicated, requiring numerous, precisely machined parts. They were finicky, jamming in mud, dust, or cold. They were heavy, often weighing 10 to 12 pounds loaded. They were expensive, costing 3 to 5 times as much as a conventional bolt-action rifle. And most critically, they weren't reliable enough for general infantry issue. Military establishments worldwide looked at these experimental rifles and concluded that semi-automatic technology wasn't ready for prime time. The bolt-action rifle was good enough. It was proven. It was cheap. It was reliable. Why spend enormous sums developing and producing an exotic semi-automatic rifle when bolt actions worked perfectly well? The United States Army might have reached the same conclusion if not for one man's vision and one man's genius. The visionary was General Douglas MacArthur, Chief of Staff of the U.S. Army from 1930 to 1935. MacArthur had served in World War I and understood the limitations of bolt-action rifles in modern combat. He'd seen how German machine guns had massacred attacking infantry, how defensive firepower dominated the battlefield, how the side that could deliver more bullets faster usually won. In 1929, MacArthur directed the U.S. Army's Ordnance Department to develop a semi-automatic rifle suitable for general infantry issue. Not a specialized weapon for select troops, but a standard-issue rifle that would replace the bolt-action Springfield in every soldier's hands. The specifications were demanding. The rifle must be reliable under all conditions, accurate to at least 500 yards, simple enough for conscripts to operate, durable enough to survive combat, and capable of firing the standard .30-06 Springfield cartridge used in American machine guns and the existing Springfield rifle. The genius who would fulfill that vision was a quiet, methodical Canadian-American named John Cantius Garand. John Cantius Garand was born on January 1st, 1888 in Saint-Rémy, Quebec, Canada, the first of 12 children in a French-Canadian farming family. His parents, struggling to support their large family, moved to Connecticut when John was 11 years old. The boy, who Americanized his name to John, showed an early aptitude for mechanical work, leaving school at age 13 to work in a textile mill. But Garand wasn't satisfied with mill work. He educated himself, studying mechanics and engineering through correspondence courses and hands-on experimentation. He worked in various machine shops, absorbing knowledge about metallurgy, precision manufacturing, and mechanical design. By his early 20s, he had developed enough expertise to secure a position at a shooting range, designing and building specialized target rifles. World War I changed Garand's trajectory. In 1917, with America entering the war, the US Army needed machine guns desperately. Garand designed a light machine gun that caught the attention of the Bureau of Standards, which hired him to continue development work. Though his machine gun design wasn't adopted, his talent was undeniable. In 1919, the Springfield Armory, the US Army's principal firearms development facility, hired Garand as a design engineer. For the next decade, Garand worked on various projects, including an improved version of his light machine gun. But his true passion was the semi-automatic rifle. He was convinced that the technology could be made reliable enough for military service if approached correctly. While other designers pursued complex, multi-part solutions, Garand focused on simplicity, durability, and foolproof operation. When MacArthur issued his directive in 1929, Garand was ready. He already had several semi-automatic rifle prototypes under development. Now he would have official support and funding to perfect his design. What followed was one of the most intensive weapons development programs in American history. Garand wasn't working alone. Other designers, including noted firearms inventor John Peterson, were also developing semi-automatic rifle designs. The competition was fierce. The stakes were enormous. The rifle that won would equip the entire US Army and potentially change the nature of warfare itself. Garand's approach differed fundamentally from his competitors. While Peterson's design was elegant and sophisticated, featuring a complex toggle-locked action similar to the famous Luger pistol, Garand pursued brutal simplicity. His design used a gas-operated rotating bolt system with only a handful of major components. Gas tapped from the barrel drove an operating rod that unlocked the bolt, extracted and ejected the spent cartridge, cocked the hammer, and chambered a fresh round, all in a fraction of a second, all using the energy from the fired shot itself. The ammunition was fed from an 8-round en-bloc clip, a metal clip that held the cartridges and was inserted into the rifle as a complete unit. When the last round was fired, the empty clip would be automatically ejected with a distinctive metallic ping, and the bolt would lock open, ready for a fresh clip to be inserted. It was brilliant in its simplicity. Fewer parts meant fewer things that could break. The gas system was self-regulating, requiring no adjustments from the shooter. The rotating bolt locked solidly into the receiver, allowing the rifle to safely fire the powerful .30-06 cartridge. And the en-bloc clip system meant that soldiers could reload in one smooth motion, clip in, bolt release, ready to fire, rather than fumbling with individual cartridges. But simplicity on paper didn't mean simplicity in execution. Creating a semi-automatic rifle that could meet military standards required solving hundreds of engineering problems. The rifle had to function in temperatures from Arctic cold to desert heat. It had to work when covered in mud, sand, or snow. It had to survive being dropped and knocked around in vehicles and generally abused by soldiers in the field. It had to maintain accuracy after firing thousands of rounds. And it had to do all of this while being affordable enough to produce in the hundreds of thousands. The testing program was brutal. Prototypes were subjected to endurance testing. firing thousands of rounds without cleaning or maintenance. They were frozen, then heated, then frozen again. They were dunked in water, covered in mud, and dropped from heights. They were deliberately abused in ways no soldier would ever abuse them, just to find the breaking point. Garand's early prototypes failed. Components broke, actions jammed, springs weakened, accuracy degraded. He would return to his workshop, analyze the failures, redesign the problematic parts, and try again. This cycle repeated hundreds of times over nearly a decade. The competition with Pedersen was particularly intense. Pedersen's rifle was in many ways more sophisticated. It was smoother shooting, had less felt recoil, and in controlled conditions, often outperformed Garand's design. Senior officers favoured it. The Chief of Infantry recommended its adoption. But Garand's rifle had one critical advantage. It was more reliable under adverse conditions. When covered in mud, the Garand worked. The Pedersen jammed. When frozen solid, the Garand thawed and functioned. The Pedersen required extensive cleaning. When subjected to extended firing without maintenance, the Garand kept shooting. The Pedersen broke. In 1932, after exhaustive testing, a board of officers recommended the Garand design for further development. Pedersen protested. Additional tests were ordered. The competition dragged on. But gradually, inevitably, the evidence mounted. Garand's rifle simply worked better in the conditions actual soldiers would face. On January 9, 1936, the U.S. Army officially adopted the M1 Garand as the standard service rifle for American infantry. It was designated the U.S. Rifle Caliber 30 M1. The M1 Garand was born. John Garand had spent 17 years developing his rifle. He held 53 patents related to its design. Under the rules governing government employees, he received no royalties, no compensation beyond his regular salary. He would die in 1974 with a modest government pension, having never profited from the millions of rifles bearing his name. But his rifle would change the world. Adopting the M1 Garand was one thing. Actually producing it in sufficient quantities to equip the entire US Army was something else entirely. The rifle was significantly more complex than the bolt-action Springfield it was replacing. Where the Springfield had roughly 50 major and minor parts, the M1 Garand had over 70. Many of these parts required precision machining to tolerances measured in thousandths of an inch. The gas system components had to be exactly right, or the rifle wouldn't function reliably. The trigger group was particularly complex, requiring skilled assembly. Springfield Armory, where Garand worked, had the expertise, but not the capacity to produce rifles in the quantities the Army would need. Private manufacturers would have to be brought into the program. But this created its own problems. The rifle's complexity meant that many existing gun manufacturers lacked the specialized equipment needed to produce certain components. New machinery had to be designed and built. Manufacturing processes had to be developed. Workers had to be trained. Production began slowly. The first M1 Garands were delivered to Army units in 1937. By 1939, only about 50,000 had been produced, enough to equip a few divisions, but nowhere near enough for a full mobilization. Many Army officers, particularly those from the old school, were skeptical. The rifle was new, unproven in combat, expensive. Some advocated returning to the simpler, cheaper Springfield. Then came September 1st, 1939. Germany invaded Poland. World War II had begun. Suddenly, the urgency of rearmament became undeniable. The Army needed rifles, lots of rifles, fast. Springfield Armory ramped up production. Winchester Repeating Arms was brought into the program as a second manufacturer, retooling its Connecticut facility to produce M1 components. The process was neither quick nor easy. Winchester's first M1 Garands weren't delivered until 1941. And early production was plagued with quality control issues as workers learned the intricacies of the design. By December 1941, when Japan attacked Pearl Harbor and America entered the war, approximately 600,000 M1 Garands had been produced. This sounds like a large number until you realize that the US Army would eventually grow to over 8 million men, each of whom would need a rifle, The majority of American soldiers in 1941 to 1942 still carried the old Springfield bolt action or the even older M1917 Enfield, a modified British design left over from World War I. The War Department faced a critical decision. Should they abandon the M1 Garand program and return to producing the simpler, faster to manufacture Springfield bolt action? Some officers advocated exactly that. The country was at war, every rifle was needed immediately, the Springfield was proven, simple and could be produced much faster. But the advocates for the M1 Garand won the argument with a simple question. Do you want to send American boys into combat with an inferior weapon when a superior one is available? The answer was no. Production would continue. It would be accelerated. Additional manufacturers would be added to the program. American industry would solve the production problem. And solve it they did, in spectacular fashion. What happened next was one of the great industrial achievements of World War II, less famous than Liberty ship production or B-24 bomber manufacturing, but no less impressive. By 1943, M1 Garand production exceeded 100,000 rifles per month. Springfield Armory and Winchester had perfected their manufacturing processes. International Harvester, better known for making farm equipment, had converted a factory to rifle production and was delivering thousands of M1s monthly. Harrington and Richardson Arms Company joined the program in 1943, adding yet more capacity. The key to this production miracle was a uniquely American approach to manufacturing, interchangeable parts and assembly line production techniques perfected by the automotive industry. Every AMI M1 Garand component was manufactured to precise specifications that allowed any part to fit any rifle. A trigger group made at Springfield Armory could be installed in a rifle assembled at Winchester. A barrel made by International Harvester could be fitted to any M1 receiver. This interchangeability had enormous implications for field maintenance. If a part broke in combat, an armourer could replace it with a spare without hand-fitting or specialised tools. Damaged rifles could be cannibalised for parts to keep other rifles running. The entire logistics chain was simplified, but achieving this interchangeability required manufacturing precision that was at the time at the cutting edge of industrial capability. Each critical dimension had to be held to within 2 to 3 thousandths of an inch, about the thickness of 2 sheets of paper. For some components, tolerances were even tighter. This level of precision required specialised machine tools, skilled setup operators, and rigorous quality control. The quality control was particularly impressive. Every M1 Garand was test-fired before leaving the factory. Not just once, but through a complete function test that verified that all systems operated correctly. Random samples from each production lot were pulled for extended endurance testing, firing hundreds of rounds to ensure that this batch of rifles met specifications. Rifles that failed any test were torn down, the problem identified and corrected, and then retested. The result was a weapon of remarkable consistency and reliability. An M1 Garand made in 1943 by International Harvester would function identically to one made in 1944 by Winchester. This consistency meant that training could be standardized, that soldiers could pick up any M1 and know exactly how it would perform. That battlefield experience with the weapon applied universally. By the end of World War II, American industry had produced approximately 4.5 million M1 Garand rifles. To put this in perspective, Germany produced roughly 14 million Kar 98K rifles during the war. But Germany also produced numerous other rifle types, submachine guns and semi-automatic rifles, spreading their production capacity across multiple weapon systems. The United States had made a conscious decision to standardize on one rifle design and produce it in overwhelming quantities. But numbers only tell part of the story. The real question was, how would this revolutionary weapon perform in actual combat? The American soldiers who landed in North Africa in November 1942 during Operation Torch represented the first large-scale deployment of a military armed entirely with semi-automatic rifles. Not every soldier had an M1 Garand yet. Some units still carried Springfields, and Marines largely used bolt-action rifles until 1943. But the majority of Army infantry were equipped with Garand's design. The landings initially faced Vichy French forces, who surrendered after a token resistance. but the Germans quickly moved units into Tunisia. And by late November 1942, American troops were facing Wehrmacht infantry for the first time. The Germans were confident. They were veterans, many with years of combat experience. They had superior tactics, superior training, and they believed superior weapons. Their Kar 98 K rifles were accurate, reliable, and in skilled hands, deadly. Their MG 42 machine guns were the best in the world, capable of firing 1,200 rounds per minute. Their tactics emphasized maneuver, combined arms, and aggressive leadership. American infantry, by contrast, were green troops with no combat experience, led by officers who had never heard a shot fired in anger. The early engagement supported German confidence. At the Battle of Kasserine Pass in February 1943, German forces under Erwin Rommel inflicted a sharp defeat on American units, demonstrating superior tactical sophistication. American infantry showed a tendency to bunch up under fire, to hesitate when decisiveness was needed, to rely too heavily on their weapons, and not enough on maneuver. But even in these early defeats, German after-action reports noted something unusual. When American infantry did stand and fight, their volume of fire was extraordinary. German soldiers reported being suppressed by what they thought was machine gun fire, only to realize afterward that they'd been facing riflemen. The Americans, even when tactically outmaneuvered, could deliver devastating firepower. Unteroffizier Hans Schmidt, a squad leader in the 10th Panzer Division, wrote in a letter home about an engagement near Kasserine, "The Americans fight strangely. They don't maneuver well, and their officers seem uncertain. But their firepower. My God, their firepower. We attacked an American position, perhaps 20 men. We expected rifle fire, maybe a machine gun. Instead, it sounded like we were assaulting a fortified bunker. Bullets everywhere, continuous fire. We took 3 casualties before we even saw the enemy. Friedrich was hit twice in the chest before he could work his bolt for a 3rd shot. The Americans just kept shooting." Senior German commanders initially dismissed these reports as exaggeration or excuse-making. Of course, American positions put out heavy fire. They probably had multiple machine guns, but as more reports came in from different sectors, from different units, all describing the same phenomenon, the truth became undeniable. The Americans had equipped their infantry with semi-automatic rifles. All of them. The implications were discussed at high levels of the Wehrmacht command structure. Field Marshal Erwin Rommel, commanding Axis forces in North Africa, specifically inquired about American small arms in March 1943. The report he received was sobering. According to captured soldiers and intelligence analysis, the standard American infantry rifle was a semi-automatic weapon firing 8 rounds before reloading. It was reportedly reliable, accurate, and capable of rapid fire. More concerning, it appeared to be issued not just to specialized troops, but to every rifleman in the American infantry. Rommel understood immediately what this meant. Firepower was the foundation of infantry combat. The side that could deliver more bullets more accurately usually won firefights. By arming their infantry with semi-automatic rifles, the Americans had fundamentally changed the firepower equation. A single American squad, 12 men with M1 Garands, could put out as much firepower as a German platoon with bolt-action Mausers. The German advantage in tactics, training, and experience could partially offset this firepower disadvantage, but only partially. And as American troops gained combat experience, that offset would diminish. Rommel requested that similar semi-automatic rifles be developed and issued to German infantry. The request was noted, filed, and essentially ignored. Germany was fully committed to existing production programs. Retooling for a new rifle design would require resources Germany didn't have. The Kar 98K would have to suffice. As the North African campaign continued through spring 1943, American infantry began learning how to use their firepower advantage effectively. The lessons were often paid for in blood, but they were learned. The key insight was that the M1 Garand fundamentally changed infantry tactics. Traditional doctrine developed around bolt-action rifles emphasized aimed fire, fire discipline, and conservation of ammunition. Soldiers were taught to pick their targets carefully, fire deliberately, and make every shot count. This made sense when you could only fire 15 to 20 shots per minute and had to work a bolt between each shot. But with the M1 Garand, this doctrine was partially obsolete. Yes, aimed fire was still important, but the ability to fire 8 rapid shots meant that American infantry could employ suppressive fire in ways that had previously required machine guns. They could fire while moving, not accurately, but enough to keep enemy heads down. They could respond to contact instantly with overwhelming firepower, then maneuver while maintaining fire. Forward-thinking junior officers and NCOs began developing new tactics. Instead of carefully positioned soldiers firing deliberately, squads would advance in bounds, half the squad moving while the other half fired continuously, suppressing any suspected enemy position. The volume of fire didn't have to be deadly accurate, it just had to be heavy enough to keep the Germans from returning effective fire. These tactics received their first major test during the Sicily campaign in July to August 1943. American infantry, now veterans with several months of combat experience, faced German defenders who had the advantage of prepared positions and superior terrain. The fighting was brutal. German machine gun nests, positioned to cover every approach, inflicted heavy casualties on attacking Americans, but American infantry discovered that they could suppress these positions with rifle fire alone, allowing other elements to maneuver for a flank shot or grenade attack. The tactic was simple. Identify the German position. You should have half the squad pour fire into and around it, 8 shots per man, as fast as they could pull the trigger, while the other half maneuvered. German soldiers who survived these assaults described being overwhelmed by the volume of incoming fire. Even from cover, even in prepared positions, the sheer number of bullets striking around them made it nearly impossible to return effective fire. And unlike machine gun fire, which came from a single position that could be identified and engaged, this fire came from multiple riflemen spread across the assault line. You couldn't suppress it by knocking out one gunner. Obergefreiter Kurt Steiner, a machine gunner in the Hermann Göring Panzer Division, was captured during the Sicily fighting. His interrogation report included this observation. Our commanders told us the Americans were poorly trained and would break easily. They were wrong. The Americans fight differently than the British or French. They don't rely on clever tactics. They rely on firepower, overwhelming firepower. My position was hit by what I thought was 3 or 4 machine guns. When they overran us, I saw it was just a squad of riflemen. Just rifles. But they fired so fast, so much, that it didn't matter. You couldn't raise your head. You couldn't aim. You just cowered in your hole and hoped. The M1 Garand was proving its worth, but the real test was yet to come. The Italian campaign, beginning with the invasion of mainland Italy in September 1943, presented American infantry with some of the most difficult fighting of the war. The mountainous terrain favoured the defender. German forces, commanded by Field Marshal Albert Kesselring, established defensive lines across the Italian peninsula that utilised every natural obstacle. Machine gun positions covered every approach. Mortars were pre-registered on likely avenues of advance. The terrain was so rugged that tanks and artillery often couldn't support attacking infantry. This was close-range, bloody infantry combat where small arms fire dominated. And it was here that the M1 Garand's advantages became most pronounced. In mountain fighting, engagements often occurred at ranges of 100 yards or less, distances where the Garand's semi-automatic capability gave American infantry an overwhelming advantage. A German soldier in a hilltop position might see American troops advancing up the slope below him. He would fire 1 shot, then work his bolt. In that 1.5 seconds, the Americans had fired 3 or 4 shots each. By the time the German chambered his second round, the Americans had fired 8 rounds each and were reloading. The mathematics were brutal. A German platoon of 40 men with Kar 98K rifles could fire perhaps 600 rounds per minute if they were expert marksmen firing as fast as possible. An American platoon of 40 men with M1 Garands could fire over 1,200 rounds per minute, double the firepower from the same number of men. But it wasn't just the volume of fire, it was the flexibility it provided. American soldiers could fire, move, fire again without breaking their rhythm. German soldiers had to pause, work the bolt, reacquire their target, fire. That pause, that brief moment of mechanical action, was when they were most vulnerable. The Battle of San Pietro in December 1943 illustrated this dynamic. American infantry from the 36th Infantry Division assaulted German positions in the hills around the small Italian town of San Pietro in Fene. The Germans held the high ground with interlocking fields of fire and prepared defensive positions. By every measure of military science, they should have massacred the attackers. They inflicted heavy casualties. The battle was a bloodbath. But they couldn't stop the American advance. Every time German soldiers fired, they drew a storm of return fire that forced them back into cover. American soldiers, even while taking casualties, could maintain fire while moving. Not accurate aimed fire, but enough bullets flying to keep German heads down. Private First Class Felix Branham, a rifleman in the 36th Division, later described the assault. We knew they were up there. We could see their positions. When we started moving, they opened up with everything. Rifles, machine guns, mortars. Guys were hit, going down screaming. But we just kept shooting back. My M1 was burning hot from firing so much. I'd fire 8 rounds, reload, fire 8 more, reload again. I must have gone through 40 rounds in the first 5 minutes. The Germans couldn't keep their heads up long enough to aim properly. We just overwhelmed them with firepower. Branham's experience was replicated thousands of times across the Italian front. American infantry, often with inferior tactical positions, overcame German defenders through superior firepower. It wasn't elegant, it wasn't efficient, it was bloody and costly. But it worked. German commanders recognized the problem. General Oberst Heinrich von Wittinghoff, commanding the German 10th Army in Italy, noted in a January 1944 report, "The American infantry weapon superiority, particularly their semi-automatic rifles, compensates for their tactical deficiencies. We have been forced to increase our automatic weapons allocation to infantry units to maintain parity of firepower. This creates supply problems, as automatic weapons consume significantly more ammunition than rifles." The Germans were trying to solve the problem by adding more machine guns to their infantry squads. But machine guns were heavy, required crews of 2 or 3 men, needed sustained fire support from ammunition bearers, and could be suppressed by concentrated fire on their position. The Americans had solved the same problem by giving every rifleman a weapon that delivered much of a machine gun's firepower in a portable, individually operated package. The Anzio landings in January 1944 presented a different challenge. Instead of mountains, American forces faced flat terrain and determined German counterattacks. The beachhead was confined, unable to break out and subjected to constant German artillery fire and infantry assaults. For 4 months, American and British forces clung to the Anzio beachhead while German forces attempted to drive them into the sea. The fighting was reminiscent of World War I. Static positions, constant artillery fire, periodic infantry assaults across open ground. It was in this grinding attritional battle that the M1 Garand proved its durability. The rifle was constantly exposed to mud, sand, and saltwater spray. It was rarely cleaned properly. There wasn't time or opportunity for meticulous maintenance, yet it continued to function. Sergeant John Patterson, a squad leader in the 3rd Infantry Division at Anzio, wrote in his diary, "3 weeks since we landed. My rifle hasn't been properly cleaned since we hit the beach. I wipe it down when I can, keep the bolt lubricated, but that's it. We're in foxholes that fill with water every time it rains. Everything is wet, muddy, covered in grit, but the Garand just keeps working. I put hundreds of rounds through it, and it hasn't jammed once. Some of the guys have had issues, bent clips mostly, but the rifles themselves just keep going." German forces attacking the Anzio perimeter discovered that assaulting American positions was suicidal. The volume of fire that erupted from American foxholes was beyond anything German infantry had experienced on the Eastern Front or anywhere else. German after-action reports from Anzio repeatedly noted that attacks foundered, not due to artillery or tanks, but due to small arms fire from American infantry.